Okay, we're going to do the last page of exploring oscillation graphs, or at least the top of it. We're just practicing finding the equilibrium, position, amplitude, period, frequency from the graphs. Okay, so the amplitude here decreases a little bit as we go, so we'll just find the initial amplitude. So it looks like we start up here at 65 centimeters, and we end down here somewhere like 0.48, so 48 centimeters, something like that. So the amplitude is not this entire amount, but the distance from the equilibrium point, which is somewhere here in the middle. Right? So amplitude, amplitude. So that entire amount is twice what we want. So that entire amount is the difference between those two positions, but we want to divide that by 2 to find our amplitude. Which will give us about 8.5 centimeters. Okay, so the equilibrium point is the point in the middle of the motion, the point which is oscillating around. So we can find that in a few ways. Once we have the amplitude, we could just add or subtract from the bottom. If we don't, though, what we're talking about is really the average of the top position and the bottom position. That's our equilibrium point, and that's looks like about 56.5 centimeters on the graph. So period and frequency are about time. It's about the number of cycles per second, or the number of seconds per cycle. And we want to do as accurately as we can. We want to take as much data as we can here. So I'm going to start at the top of that one and go to the top of that one. I'm going to use as much of the scale as I can. So I'm going from 0.2 seconds there to about 6.4 seconds there, and that is 1, 2, 3, 4, 5 cycles. So the period is that difference in time, right, 6.2 seconds it took to get from 0.2 to 6.4, divided by 5 cycles, which is 1.24 seconds per cycle. The frequency is just 1 over the period. So we take the reciprocal of that and we get 0.81 cycles per second, 0.81 hertz. Okay, for the second one, same ideas. The top is here at about 0.58 meters. The bottom is here at about 0.51 meters, which means that the total distance between there is 7 centimeters. But we only want half for the amplitude. So our amplitude is 3.5 centimeters. And the equilibrium point is that average position, or I can add from the bottom up 3.5 centimeters and get 54.5 centimeters, subtract from the top down, do the average however you'd like to do it. Alright, so if we go, this is a pretty recognizable point in the cycle. It's not quite at the not quite at this line, which may or may not be which is not quite the equilibrium point anyway. But I can recognize that point. So I see it there, I see it there, 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 and there. So I've gone through 1, 2, 3, 4 cycles, and I started at 1 second, and I ended, let's say, right about 2.73 seconds, let's say. And I started at 1 second. So that took 1.73 seconds to happen, and if we count the cycles, we'll see that there are 4. 1, 2, 3, 4. So I get 0.4325 seconds per cycle. So this goes through fewer seconds. It takes fewer seconds per cycle, so this one is oscillating more rapidly. The frequency is 1 over the period. So in this case, we'll have a relatively high frequency, to be higher than the last one. So we're looking at like 2.31 hertz.